So this is an excellent question dealing with our molar mass calculation. In molar mass is, oops, sorry about that, is our molar mass is equal to grams per mole. And so the question is asking us, what is the mass of 1.2 times 10 to the exponent 24, that's what that E means, I just couldn't do the exponent here, of molecules of magnesium sulfate. So there are a few things that we need to know about this question, or can pull from the question. The first thing that we can pull, and we need to remember that 1 mole of magnesium sulfate is equal to 6.02 times 10 to the 23 grams of particles, okay, or molecules. Okay, so that is a constant that we need to be aware of. The second thing that we need to be aware of is that within all of these particles, okay, actually what we can measure with a scale is what's called the molar mass. And for us, our molar mass we can determine by adding up the various molecular weights of the elements that make up the compound. Okay, so when we add up magnesium, which is 24.31, and we add that to sulfur, which is 32.06, and we also add 16 for our molecular weight of oxygen, but keep in mind we have 4 of those, so we must multiply that by 4. We should get a total of 120.377 AMUs, or atomic mass units. Okay, so these are things that we can use in our quest for our answer, these key concepts here. So essentially what we're going to do is we're going to use our number that's given to us. So imagine we have 1.2 times 10 to the 23 grams of magnesium sulfate, okay? And we know that our formula, we have, which is 10 to the 24, that's key there, that exponent, okay? So it looks smaller than what we actually have when we only have 1 mole of magnesium sulfate. So 1 mole for us, yes, it's 6.02 times 10 to the 23, but 1 mole actually is 123 or 120.37 AMUs, or grams, as we'll come to know it. So even though the numbers look really similar, they're actually very, very different in comparison. The 1.2 times 10 to the exponent 24 is much larger than our exponent to the 23. Okay, so we're going to set this up in terms of a dimensional analysis. So 1.2 times 10 to the 24 molecules is what we're given. Okay, and we're going to have that over 1 because we don't have 2 moles or 2 molecules of magnesium sulfate. Okay, so if we had more than that, then we'd have to consider that in our calculation. We're going to use our unit calculation here. The 1 mole is equivalent to 6.02, so we have 1 mole over 6.02 times 10 to the 23 molecules. Okay, so the name of the game here is to set up our unit fraction so that things will cancel out. So our molecules will be able to cancel out, as we have molecules up here in our numerator and we have molecules down here as well. And we're also going to use the molecular weight given to us as well. We're going to multiply that by 100, or we're going to have 120.37 over 1 mole. And that's telling us, in terms of chemistry, is that every 1 mole of magnesium sulfate is equivalent to 120.37 grams, which equals 6.02 times 10 to the 23 particles. Okay, so particles in terms of grams. So it's an incredibly large number, and this is why we often just refer to it as a mole, okay, or Avogadro's number. So as we can see here, what I'm going to actually do is start canceling out units. So the name of the game is to only have grams left, okay, in terms of our question. So we actually, in terms of our 120.37, we could actually consider that grams. So molecules can cancel out as well as our moles cancel out. So essentially what we're going to do now is we're going to multiply 1.2 times 10 to the 24 by 120.37, and we should get an answer of 1.44444 times 10 to the 26. Okay, and we're going to have that over our Avogadro's number, which is 6.02 times 10 to the 23. Okay, so we're taking into account Avogadro's number because we have multiplied the given number of molecules by our atomic weight. Okay, which is that 120.37. But that is only equivalent to 6.02 times 10 to the 23 molecules. And we clearly don't have that, because if the question asked that of you, if it said, what is the mass of 6.02 times 10 to the 23 molecules of magnesium sulfate, well, you should simply be able to tell us that it's 120.37 grams. So that's why we still have to consider Avogadro's number in there, so we can get our mass based on this. Now, in terms of your calculator, this can actually become quite a little bit of a tricky a calculation, only because of your dividing your exponent. So keep all your decimal places until the final answer. So put in 1.44444 times 10 to the 26 into your calculator. Press divide, then press the bracket sign, because what will happen is if you just press divide and put 6.02, it will automatically divide that without considering your exponents. So put in the bracket sign and then put 6.02 times 10 to the 23 and the other bracket, and your calculator will recognize this as a whole number. And then when you press equal, you should get a number of 239.94 grams. So I hope this helps. Please let me know if you need any more assistance with these type of questions. This is a rather tricky one because we are dealing with such large numbers.